everybody, welcome to the new week. We are into week 34. So the good news about this week is we're starting a brand new unit. And I think you guys will find that this unit is a little bit easier than the last one because there's a lot of tools that we can use to solve these problems. We're not just relying on one concept. So this new unit is called Systems of Equations. So I've defined it on my nifty little notes here. If you guys didn't catch these, they're attached to the post in Teams Conversations for today. So if you go to Monday and you look at that post, there's an attachment. And also, it's in Teams Files. If you click week 34, I gave you guys copies of my cool little notes. Okay, so the definition. This means we have more than one equation grouped together. The solution to the system is an ordered pair where the x and y values satisfy both equations. The reason that happens is because each one of these is really just the equation of a line. So when they're equal, it just means they're crossing. So we're looking at a location where these lines are actually crossing. So here's what it looks like as equations. We literally just have two equations and they're grouped together with this little curly bracket. That's all it's gonna look like, just two equations. I mean, it can be something other than linear equations, but for us, it's just gonna be two lines grouped together. In a table, it just means that we're gonna pick some x values, plug them into both, and see where they're equal. And as a graph, we're gonna graph them. So taking a look, if I wanted to find a solution, a lot of us just use guess and check, and we might look at this and be like, well, what would happen if x was 0? This would be 1, this would be 0. Okay, those aren't equal. What would happen if x was 1? This would be 2, and this would be 2. Hey, wait, there's an answer. X probably has to be 1, right? But then you're not done. You need a y value also. So if I plug in x equals 1, 1 plus 1 is 2, and just make sure it works for the other one. If I plug in 1, 2 times 1 is 2, so y would be 2. Hey, look, there's our answer. So we write it as an ordered pair. Some of you guys are really good with guess and check. Me personally, I never bother. So what I would prefer to do instead of guess and check is I would probably make a table. And we'd say, well, let's try a couple of different values and see what happens. See if we get close. So if I were to plug -1 into this first equation, -1 plus 1 is 0. 0 plus 1 is 1. 1 plus 1 is 2. 2 plus 1 is 3. And 3 plus 1 is 4. I'm just plugging it in here for x. Now let's try the second one because we're trying to find an x value that makes both of these things equal. So 2 times -1, those aren't equal. That's not our solution. 2 times 0, those aren't equal. Not our solution. 2 times 1, these are equal. That's our solution. And if we had kept going, 2 times 2 and 2 times 3. So this is that spot where they're equal to each other. When x is 1, the y value is 2 for both of them. So that's our solution. So just confirming, guess and check or a table, we got the same thing. We're just looking for wherever we plug in an x and the y is the same. Now, as a graph, visually, I think this is the easiest one to see. So you would have to remember how to graph. And if you don't, remember you've got that Desmos tool. So desmos.com will graph them for you if you had enough graphing in the last couple weeks. I'm gonna go ahead and graph. So I'm gonna plot this first one. This has a y-intercept at 1. And it has a slope of 1, which means I'm gonna go up 1 over 1. And I can extend that line as far as I want just to make it really accurate. Okay, so I'm just gonna draw that in with a nice straight edge. Okay, there's my first line. Now I'm gonna go back and I'm gonna graph the second one. So this line right here has a y-intercept at 0 and it's got a slope of 2. So I'm gonna go up 2 over 1. Hey, look, that's where they're crossing. I could keep going to be accurate. Up 2 over 1, up 2 over 1. I could even go down 2 and left 1. I'm gonna draw on that line. And our solution is just where these two lines are equal to each other, meaning where they're crossing. So this was that one. And this is our second one. So let's look for that crossing location. Right here, see where they're crossing? This has an x value of 1 and a y value of 2. So 3 different ways we just confirmed that solution. So the solution to the system is the ordered pair 1, 2, meaning that if you plug in x equals 1 and y equals 2, it satisfies both equations. And we can also say this is where they cross. So when x is equal to 1, both of those lines have y values of 2. So that's it. We're identifying that we've got a system of equations, so more than one equation is grouped together. Its solution is that point where they cross. You can either find this by graphing it and looking for where they cross, plugging in numbers that you're guessing and seeing where they're equal, or just random guess and check. This won't work forever, neither will this. This will, but sometimes if the numbers are really big and obnoxious, you are not going to want to do that every single time because your numbers could get real crazy. But Desmos would be great, or a graphing calculator. All right, so for your turn today, you guys are just going to be looking at 3 different representations of a system, and you are just going to identify which one of these is its solution. So you're looking at a system that's listed as just 2 ordered pairs grouped together. You need to pick which one of these is the correct solution, so plug it in, see if it works. This one is given to you in the form of a graph. You're just going to identify which of those 3 is the solution to the system. And finally, you're given a table, and you're going to identify which one is the solution. So at this point, you can pause and try them on your own, and then push play when you're ready for the answer, or I'm just going to go through and find the correct answer.